In calculus, we will often need to determine the equation of a line given a point on the line and the slope of the line. So an easy equation to use to determine this equation is the point-slope form for a line, which is y minus y naught equals m times x minus x naught, where m is the slope and x naught, y naught are the coordinates of the point on the line. Alternatively, we can bring this y naught over to the right-hand side and use the equation y equals the slope m times the quantity x minus x naught plus the y naught value. Either form works. We will be using primarily this first form in our solutions today. Let's determine the equation of a line that is parallel to a given line, 3y equals minus 2x plus 4, and containing a point 2, minus 1. So the x naught and the y naught value are easy to determine from this problem statement, and we'll have to do a little bit more work to find our slope. So let me indicate that here. The first thing we're going to do is determine the slope. So what does this idea of two parallel lines give us? Well, when two lines are parallel, we know that they have the same slope. So if we can find the slope of 3y equals minus 2x plus 4, then we know the slope of the line that we're trying to write. Now, before we try to read the slope off of this equation, we need to recognize that it's not in standard form. Standard form for a line would have the coefficient of the y on the left-hand side with the coefficient of 1, and we have a 3 here. So we need to rewrite our equation, 3y minus 2x plus 4, forcing the coefficient of y to be a 1, and to do that we need to divide every term in the equation by a 3. So when I divide 3y by 3, I simply get y. When I divide the x term by 3, I get minus 2/3 x, and then I also need to divide the constant term by 3, so plus 4/3. Now this is maybe the more familiar slope-intercept form of a line, so we can read the slope off here, y equals mx plus b, and we see that our slope is minus 2/3. So this is the slope of the line that we are trying to create, and we have the x naught, y naught value here. So rather than using these pieces of information to determine a new intercept, I'm going to substitute directly into my point-slope form. So trying to write the line, I see that I take the y and I subtract minus 1, and then I have equals our slope minus 2/3 times the quantity x minus 2. Normally, we clean this up a little bit and write y plus 1 equals the slope minus 2/3 times the quantity x minus 2. Another problem we can do, where this form comes in handy, is determining the equation of a line that passes through 2 points. So we're going to pass through the point 2, minus 3 and the point minus 1, 4. Now when we're writing out this equation, we can use either point as our point on the line. I'm going to just choose the first one. So I'm going to indicate that here. So notice that the x naught, y naught value I used matches the first point that was given. So we're still left to find our slope, and we're going to use our concept that slope is the change in y over change in x that we talked about earlier. And when we create this change in y over change in x, I'm going to take the second point, minus 1, 4, and I'm going to subtract the components of the first point. So if you notice, in the numerator, the 4 value from the second point is first, and I'm subtracting the minus 3 for the change in y. And then I'll put negative 1 from the second point and subtract 2 from my change in x. So doing this algebra, I see that my slope is minus 7/3. So the equation of my line is the y value minus my negative 3, which is the y naught, equals my slope minus 7/3 times x minus 2, or x minus x naught. And again, I'm going to clean that up by combining my negatives. to look like y plus 3 equals minus 7/3, the quantity x minus 2.